in Agent Studio today, there is effectively a particular type of architecture or design that you have for your agents. And this comprised at the high level by the agent team. The agent team encapsulates that agent network. It is the entry point for that agent workflow. And so you may have seen in other environments where we talk about workflows. This is the equivalent to that. This is the high-level entry point. The intent comes in at this level. The agents execute on that. The tools are called, of course, and then there's an output at the end of it. And this could be multi-turn. It could be single-turn or multi-turn, depending on what type of experience you're building. Right now, you're building agents that are largely in an interactive chat. So that's an example of multi-turn, where you'll be including the system prompts of the agents that are being called, plus all the conversation history to arrive at your answer and keep the state of that session going. You can also have agents that work off a single request or intent, and they just complete the request and they're done. So you'll see, I don't think you're doing any of those in the lab, but that is a common scenario. It's just a back-end process. An email comes in, I need to extract some information out of it. I need to generate some type of JSON representation of the entities I care about out of that, and that's it. I don't need any user interaction other than some type of trigger came in, gave me the content I need to work through, and I have to provide that type of output. So that's an example of what maybe we would call a background type of task or a batch task, where it'll be a single turn. And again, same entry point. You call the agent team, you provide the intent. So that agent team is needed always. This is what gets published and what gets deployed. And that code for that agent team is critically important. That is in the URL pattern when you call the agent. That is how we know exactly which agent to call. Within the agent, you can have any number of agents. So you're probably doing labs where you have a single agent right now, and that's a great place to start. So the single agent inside of an agent team has a set of tools. And when the intent comes in, the agent team is the user proxy. He's receiving the intent. He is determining the plan and selecting the agent to invoke, which of course in this case is a single agent, so it's a pretty easy task for it. And then that agent, with its system prompt and topics, is then making determinations about which tools to call and using the session history in order to make those calls, to slot the variables for tool calling as an example. So that single agent is going to have a number of these tools and or topics. And you could have topics at the supervisor level and at the agent level. You can only have tools within a worker agent. So the supervisor does not call tools. It calls worker agents call tools. In the multi-team, and again, we'll talk about why you might want to use a multi-team agent. The supervisor now is the user proxy. And so you'll be providing a very specific system prompt for it. You can apply topics to it for conversation guardrails as an example, or instructions. And its job is to then not only plan to address the intent, but also to call the worker agents, interact with them individually, and then call the next agent in the sequence. And so what you'll see in the debug view, especially in a multi-agent team, is, and you saw that yesterday during the demo, depending on the intent, is picking the right worker. And in some cases, it could be sequential. It calls this worker first, it takes the output of that and calls the next worker. It's the responsibility of the supervisor to pick when an agent is called and when the next agent is called, and to make sure that that context is available. This type of scenario where the supervisor is making the decisions, you have to carefully instruct it in how it should make those kinds of decisions, or give it a lot of examples and a lot of good instruction. So that's the high level of the design and architecture. There are many other patterns, and we'll be supporting those as we see the need arise. One you may have heard of is called Swarm. This is an example, like when a service request comes in, several different entities can try to attack it at the same time. So there's patterns for that type of approach. We don't support that today, but that is another valid pattern that people use. Another common pattern is sequential agents, where you're actually defining the chaining of agents' interactions with one another. So this is a more deterministic approach. You're not relying on the supervisor to do the planning. You're instead saying, here's my start node, here comes the intent, and I just want you to go through these series of steps to get to the final answer. And those steps could include calling an agent who can work with tools. It can be calling a large language model with just a prompt to do something. It could be some type of conditional. If you see this in the history, then take this path, otherwise take this path. It could be loops. So it's almost like a lightweight business process diagram that you're building. That is something that we're working on for a future version, because there definitely are use cases for that. So today you're working with the supervisor agent team concept, and in the future you also will have available to you the sequential workflow approach as well. So again, in the single agent, you want to be very clear on the role and persona of what that agent does. You want to give it a set of tools. Kind of best practices are about 1 to 5 tools for optimal performance. We certainly have seen successful agents using 10 plus tools, but you need to spend a lot of time testing. You need to spend a lot of time with your prompt to make sure that you're giving it enough instruction. So when do you want to go to multi-agent? So I guess the advice here is start with single agent, see how far you can get. And then if you find yourself in a situation where you're seeing a workflow in which you have very distinct types of functions or domains that need to be handled within that workflow, then that's where a multi-agent scenario is going to be helpful. And there are other ways to do this as well. I mean, you can write code that calls single agents independently that are responsible for this, or you can depend on a network like this with a supervisor to do that as well. Similarly, we suggest something around 3 to 5 agents per workflow. Once you get beyond that, that's again where you're going to need to think about how good your prompting instructions are, how good your evaluations are to make sure that it's working as expected. It just increases the complexity. So I'd say start with this kind of level of complexity and then build from there as you get more comfortable with it, especially in Agent Studio. So just some guidance here on single agent versus multi-agent. Single agents are, it's fairly obvious, I think. When you have a simple self-contained task, it's basically a small set of intents, but they're closely related, a single agent can do the job. And in fact, we find probably 90+% of the use cases so far, they can work fine with a single agent and a set of tools. You don't need necessarily multiple agents. There's a lot of advantages, a lot easier to design, maintain, faster, because you're not asking an LLM to coordinate between agents. But it's not very scalable inside that network, right? As soon as you go outside the scope of that agent, you're done. And expertise boundaries. So a single agent is going to lack some specialized skills for every part of the complex task. And that's by design. So just keep that in mind. Now, when do we go to multi-agent? This is when you have a more complex workflow. And a good example that we talk about a lot is like the recruiting workflow. There's very distinct specialized skills that you need for the various stages of hiring somebody. You need skills that know how to find good recruit matches. You need skills that know how to do something like scheduling. You don't necessarily want the same agent doing both, right? Because then you'll have to deal with instructing it to do both. You may have one that needs to go through an onboarding process. And that could be another set of workflows as well. So you see here specialized skills that are required. That's a good way to think about how to break up agents around, particularly in a multi-agent workflow. So the specialization here is that you have distinct expertise. It's almost more natural to think about the workflow this way, right? Because you're thinking about each of the kind of common interactions or personas that are involved in that kind of workflow. And you can build much more complex types of scenarios that way. We touched on this yesterday. There's a couple ways to think about partitioning agents. Kind of the two big ways to think about it is there a specific domain that the agent is going to be particularly focused on, or can you separate the workflow into separate domains? And this would be like business domains. And so this is a very large workflow, right? You got a lot of big personas that are participating in that versus something that's function-based. And this might be something more related to like the onboarding or the recruiting type of workflow, where specific functions are provided by each agent. So just to summarize, each agent should be really specialized for a specific type of task. He only uses the tools that he needs to complete that task, and you have yourself a agent that's going to perform. And if you need to do more complex workflows, you start to build more and more of these specialized agents and let a supervisor determine who's going to be performing those operations. This is a good one. It actually, so one, you're doing prompting, and you're telling the LLM, hey, you have access to these tools. You will add them to the hierarchy inside the canvas as well, but you'll also give instructions to the agent to say, if you're presented with this type of request, you should use this tool. And I've run into situations also where tool calling can make mistakes, and you have to add additional instruction, and it's dependent on the LLM to say, hey, when you pass this argument, you need to pass it like this. A good example, I was playing with an MCP. The arguments were getting passed as a single string because it was just a single argument. But the MCP was expecting a list of strings. And even though it was just a single string, the fact that format was different than what it expected broke it. I had to write a very specific instruction to say, when you call this tool with a single argument, send it like this, and here's an example of what that looks like. So those are the kinds of things you're going to want to do when you're instructing it how to use these tools. And you'll run into these situations as you're working with them, and you'll have the information in your debug log to look at as well. But what's most important about this selection, even more so than your instructions, is how good the description is of the capability that you're giving it access to. So if we start at the tool level, if I had two document tools and both of them had a generic description like a set of documents, it's not going to know which tool to call. It might call both, might call one. You're just leaving it up to chance at that point. So in that description, you say, this is a set of documents that address these types of questions, or this is a set of documents that address these types of questions. You want to give it as much context as you can as to what the tool is able to do and the kind of information that it can provide. Then when you're telling it to call these tools, you can say, hey, for these types of questions, call this one. It's going to see that description, it's going to match right up, and it's going to make a good choice. You saw yesterday when I did the multi-agent, I didn't put very good descriptions in either, right? I just said web search agent. That actually works because there was two very distinct types of agents. But if they're very closely related, make sure you give them very good descriptions about what's contained in that tool, what kind of questions it can answer. Going one step up, in worker agents, same concept. If I have two worker agents that are responsible for pulling something out of accounts, maybe one is doing the retrieval and another is doing the action of posting something. If I give it a very generic description like account business object, again, this could make bad choices there. So this account business object is responsible for retrieving this type of information. This is the type of output you can expect. And this business object is responsible for handling actions. And this is the type of functions you need to call within it. So I'm just providing these descriptions on the way up. The supervisor agent description, interestingly, or at the agent team level, is really for the human, more so than the LLM, because this is what the end user is going to be seeing. And the supervisor doesn't get selected by anything. Now, I say that that's the stat today. In the future, when we have agents that are being automated to look for other agents, these descriptions are going to become important. So you may have heard of another burgeoning standard called A to A. That's an example where agents are going to go out and look for agents that can do the job. Just like you have an agent that looks for a tool, you're going to have agents looking for other agents. And there's a way that you describe it through the interface so that it knows, oh, this is the right agent for the job. I'm going to go invoke it, and I expect it to accomplish what it says it can do. So even though today this is really just for the end user, be mindful that the landscape's going to change in the next 6 to 9 months, and agents are going to be calling other agents, and we need to be prepared for that kind of stuff.